PTFE, a multi-use polymer. What is PTFE? PTFE is polytetrafluoroethylene, also known as Teflon. PTFE is a polymer consisting of only carbon and fluorine bonds. This allows it to be an inert chemical that is useful in many household applications as well as industrial. PTFE is so widely applicable that it can be bought on Amazon for consumer use, is found on the inside of pipes, and can also be used in medical devices. To observe the characteristics that make PTFE so unique, an experiment was conducted to test its ability to withstand heat, its thermal conductivity, its durability, and its coefficient of friction. Low-carbon sheet metal was used as a comparison against PTFT's characteristics due to their similar yet different natures. Pictured below are both materials cut to size. 3 different experiments were conducted, each to test a different characteristic of the materials. PTFE and heat. The thermal conductivity of PTFE is 0.25 watts divided by meters times Kelvin, while the low-carbon steel sheet metal has a thermal conductivity of 50 watts divided by meters times Kelvin. The melting point of PTFE is 327 degrees Celsius, while the melting point of low-carbon steel sheet metal is 1,450 degrees Celsius. These numbers are important because PTFE's high melting points for a polymer make it useful in many different applications. Based on the thermal conductivities, the hypothesis in the experiment was that PTFE would transfer far less heat than the low-carbon steel sheet metal when heated up and touched to another object. To conduct this experiment, an iron was turned on. After it was allowed to heat up, a thermal heat gun was used to ensure that the temperature was above 230 degrees Celsius. Next, a towel was laid down on a surface, and then a piece of Teflon was put in between the towel and the sheet metal to ensure that the metal would not get so hot to damage the towel. The iron was then set on top of the sheet metal for 5 minutes. After the time was completed, a 30 milliliter cup was used to drop 15 milliliters of water onto the sheet metal. These steps were then repeated with the PTFE. The results are in the next slide. PTFE and heat experiment. PTFE and coefficient of friction. As discussed before, PTFE is a polymer. Low-carbon steel sheet metal is a metal alloy. PTFE is composited only of carbon and fluorine atoms. Low-carbon steel sheet metal is 98% iron, with the remainder of the atoms being carbon, manganese, copper, phosphorus, silicon, and sulfur. To conduct this experiment, water, oil, and peanut butter were set on top of both materials. Each material was then turned sideways to allow for the water, oil, or peanut butter to bead and roll off. After this was completed, both surfaces were wiped once with a paper towel. The results are in the next slide. A low coefficient of friction is one of the characteristics that polymers and metals can share. The coefficient of friction for PTFE was 0.06 to 0.1, while the coefficient of friction for low-carbon steel sheet metal was 0.15. These low coefficient of frictions also make these materials ideal for different uses. PTFE and non-stick experiment. Below are the pictures of each material after the singular paper towel swipe. Durability of PTFE. PTFE has a very low hardness. This is important for the fields in which it is used for because if it comes in contact with other materials that are softer than it, it may damage them. This is one of the reasons that PTFE is often chosen over metals. The hardness for PTFE is 1.3 to 1.8 megapascals, while its tensile strength is 20 to 30 megapascals. Low carbon steel sheet metal has a hardness of 120 megapascals, while its tensile strength is 250 megapascals. To observe these characteristics in the materials, they were set next to each other on a towel. Stainless steel kitchen shears were then pressed into each material and dragged. It is important to note that these results may not be reliable due to the thickness difference in both materials. PTFE and durability experiment. Conclusion. The results of the experiments agree with the characteristics of each material. While both materials have similar characteristics, they are very different materials. Based on the experiment, it's evident why one material may not be able to be used in a situation where the other one is.